It takes me forever, like forever. Okay, perfect. So at this point, I realize that at negative 1 comma 8, look what the function is doing. It's increasing and then decreasing. So what type of point must negative 1 comma 8 be? What type of point? Negative 1 comma 8 is what type of point? A relative what?
Maximum.
Maximum. Good. Notice that the derivative must change sign. So if the derivative does not change sign, if on this side is negative and on this side is negative, negative 1 comma 8 is not a point of extrema. But because the derivative is increasing, is positive, and then it's 0 or undefined, and it's negative, this is typical for a relative max. Okay, we're moving on to the point 1 comma 4. So on the left of 1 comma 4, the derivative is negative. On the right of 1 comma 4, the derivative is positive. What type of point must 1 comma 4 be for sure? Savannah?
Would it be the relative minimum?
Very good. There is no other way. The derivative is like this, and then the derivative is like this. The slope of the tangent line, and then it comes to a minimum, and then the slope of the tangent line starts being positive. So this is what we just learned, what we get from the derivatives about the function. So the situation is this: positive, 0, negative, or positive, undefined, negative. So this is for f prime. If f prime follows positive, 0, negative, or positive, undefined, negative, this is a relative. This gives this scenario. These two scenarios give relative max. Again, for f prime, in which we have negative, 0, and positive, or negative, undefined, and positive, these two situations give a relative what? Very good. Relative min. Okay, let's continue with other examples and find the critical numbers and study whether they give a maximum or a minimum. In this situation, we found two critical numbers, both turned into a relative extrema. The first one into a relative max, and the second one into a relative min. Not all critical numbers turn into points of extrema. Please feel free to choose from 1 through 34 on page 201. Anything you want, or I will choose. Um, 33 caught my eye. If you would like to choose the next one, that would be great. If not, we'll continue. Any questions so far on critical numbers, sign of the derivative, and max min? That's what we studied so far. So here's 33, and we have g of x equals the square root of x squared plus 2x plus 5. I don't care for their requirement at this point. I only care about critical numbers, max min, and increasing or decreasing intervals. So coming back here just for a moment, what will you say? Between negative infinity and 1, union 1 to infinity, what is the function doing? Lake?
Increasing.
Yes. What is the function doing between negative 1 and 1?
decreasing.
Perfect. So these are the intervals of increasing, decreasing. Okay, good. So how do we start on this problem? We want to determine critical numbers, max, min, and intervals of increasing, decreasing with the table. Where is the starting point? Yes, I'm ready.
The derivative
Of course.
g of x.
G prime. Awesome. Thank you. Anyone would like to help us with the derivative?
2x plus c.
Anyone, please?
Do we have to first make it an exponent instead of a square root?
No, not for the square root. Very good point. But if this is like this, definitely. But not for the square root because we have a very straightforward formula for the square root. I would not recommend that. Ready.
1/2 parentheses. Yep.
My markers are drying out.
I don't know what the formula is. So
Yeah,
I don't know if we could go over the formula.
So the square root of x prime, we know that. This is carved in stone. We don't want to forget this. We don't want to come back to it. But this is a function, right? The square root of a function prime, which is 1 over the same thing. The square root of the function times the function prime. We cannot forget this. If we get stuck on this formula, we can't advance.
So would it be so x plus 2?
That's it.
Okay.
So please remember, this is the same thing. Here we don't write x prime because it's 1, but it's the same formula. Okay? So the square root of a function prime is 1 over 2 the square root, the same thing, but times f prime. Okay, good. So now we have g prime of x equals 0, and g prime of x equals undefined. So remember, critical numbers can come from two possible sources, either from g prime being 0 or from g prime being undefined. When will g prime be undefined for this function? When will g prime be undefined? Look at the function g prime, all this, and tell me when will that function be undefined, in which situation?
If x squared plus 2x plus 5 equals 0,
Excellent, great job. Who said that?
I did.
Thank you. Of course. But if this is 0, then this is 0. And we don't have anything. So obviously x squared plus 2x plus 5 is not going to be 0. Good. So nothing coming from here. And when I said this equal to 0, when I said this the function equal to 0, what do I need to, the derivative equal to 0, what happens? How do I continue? So I would write that g prime is 0. G prime is 2x plus 2 over 2 the square root of x squared plus 2x plus 5 equals 0. So then what happens here? How do I continue? When is a fraction 0?
When it's 0 over 0.
Careful. 0 over 0 does not equal 0. 0 over 0 is indeterminate.
Even 2x plus 2 equals 0.
Thank you very much. A fraction, thank you, Amanda. A over b is 0 only when the numerator is 0, which means 2x plus 2 equals 0. Can anyone give us x?
Negative
-1.
Very good. So this is the only critical number that the function has. Get the table, please. Ready? X, f prime, and f of x. We have to find the domain of this function. So we have to write that x squared plus 2x plus 5 must be what? For this function to exist.
-1.
Greater than or equal to 0. The square root exists only from positive numbers and 0. If it's -1, we are in trouble.
So we never want it to equal -1?
The square root has to be taken from positive numbers and 0. And also, the answer is always positive or 0. I have not reached the critical number yet.
So is this one of the cases that you were saying where?
No, what I'm saying is when I start the table, I have to start with the very first row, which is the domain of the function. Of course, I will put -1 in there. But what if -1 is outside of the domain? So it's a very good point. So first, domain. I cannot start the table. I cannot put anything in the table before I ask what is the domain. First, I have to ask what is the domain. What if the domain is 0 to infinity and I have -1? I'm done. There is no critical number. I've got a critical number, but it doesn't mean anything yet. I have to start with the domain. If this is my first priority for any function, the domain of the function. So that's why I didn't even think of putting -1 in the table, because I don't know what the domain is. So then how do we continue? So I look at the function. The function is the square root of x squared plus 2x plus 5. And I know that the square root has to be taken from positive and 0. Therefore, the entire quantity under the square root has to be greater than or equal to 0. It happens that it is, because if you want to use the quadratic formula to just solve for, set it equal to 0 first to see what happens, then we have -b plus or minus b squared minus 4ac over 2a. Not real. This is a negative number. They're not real. And since this is a quadratic function with a minimum, and it never touches the x-axis, this will always be positive. No matter what. It never touches the x-axis, let alone become negative. So this is safe. It's okay. It happens that this function is defined everywhere, so then I can put -1 in the table. And I can put 0 in the row for f prime under -1. So I'm okay with that, because I know that the domain is any real number. That's okay. Are you with me so far, everyone? Do you understand why I had no choice but to start with the domain, and I always start with the domain? Is that clear?
Yeah, I get it.
Okay, now I do have to plug in -1. So -1 squared, so it's 1. 1 plus 5 is 6. 6 minus 2 is 4. How nice. And the square root of 4 is? We know the square root of 4 is?
2.
Good. Now I also need these limits. I always need these limits moving forward. So which of these three terms is the most powerful one? Good. So if it's x squared, when I plug in negative infinity or infinity, doesn't matter, because x squared. Good. And when you take the square root, what should I put here as the limit?
infinity and positive infinity.
But I can't. It's the square root. The square root can never have an answer that is negative. The
But
square,
it's squared, right?
right. But the square root of a positive number or zero will always be positive or zero. Okay,
Goes to positive infinity, right?
Yes, so it's only positive infinity, but I need to explain this because this is a very common confusion. Students say that if you take the square root from both sides and you get plus or minus 2, they conclude that the square root of 4 equals plus or minus 2. False. It's from here, this is the absolute value, which is 2. From the absolute value, we get these two symbols. The square root of 4 is only 2. The opposite of the square root of 4 will be negative 2. Is that clear? This concept is extremely important to understand. You can never get a negative number here, ever.
I get that, but what I was thinking
Yes?
is we're putting in negative infinity for x, and x is squared under the square root.
Yes.
And if you square, or if you square a negative number, it comes out positive.
Correct.
So you can put negative infinity in.
So when you take
But
the
it's
square
because
root
it's
from that, what do you get? I was asking, what do you get when you apply the square root to that?
Oh, okay. Yeah, that makes sense.
Okay, good. So now we understand. Good. So now I have to study the sign of the derivative. And then I have to make sure that these two rows work well together. If not, like it happened by accident a minute ago to 20 minutes ago, I have to go back to the drawing board. So let's study the sign of the first derivative.